Hi, everybody. Thanks, Green. Welcome to my talk around building .NET apps on AWS. So for the next, I'll probably talk for around 45 minutes. I'll go through quite a bit of code as well. So I could slow down. I'll really see how things are going. So who am I? What am I doing here? That's me doing the side eye. So my name's Derek. I'm actually a developer advocate at AWS, building cloud native apps in the majority of cloud platforms for the last 10 years. I built a startup in Azure about 7 years ago. I worked for consultancies, and then I joined AWS nearly 6 years ago. Since then, I've been helping developers build on the platform, having lots of conversations with developers and helping them to get through any speed bumps along the way and help them produce beautiful apps. I'm originally from Ireland. This is an Irish accent. However, I do live in Australia. I'm the developer advocate for Australia and New Zealand, and I currently live in Perth. This is the first time I've been to Adelaide in 3 years. Previously, I was the AWS solutions architect for Adelaide. I used to come here every second week, and I see Adelaide is thankfully not changed much in 3 years. So I'm happy to do that because I know where all the pubs are, where's good food, and all of that great stuff, and nice coffee as well, and where to get that. So thank you, Adelaide, for not changing. Okay, so today I'm actually going to take you through how I've built an app that we use at AWS. We use it at all of our major conferences. So we have our big one at reInvent once a year in November in Las Vegas. It's as horrendous as it sounds. There's 45,000 people there. It's crazy. We're also using this app across the globe. So we have global summits. There's been one in Sydney this year. I've been to one in Singapore. We have them across Europe and North America. And this app is used across all of them. But it didn't start out like an app. Like any good idea, you need a why. So why was this built? So has anybody ever been to a tech conference? A few people, yes, awake, yes. So you may be familiar with booths at tech conferences where people are trying to engage you. And at AWS, what we did was we would ask developers, what's your favorite programming language? And we would store the results on this thing here, a really rudimentary whiteboard. And of course, then we'd ask other questions like, what's your favorite service? Or, which comes here, or what service would you like to know more about? Which comes here. And as you can see, as you ask more and more questions, the complexity of what you're asking and how to actually record it becomes hideous. And these are my hideous whiteboards. And so what we did, we sat down and went, there's got to be a better way to do this. And that's why we came up with the idea of DevPulse. And that's what I'm going to go through today, how we designed it, built it, and the lessons that we have learned along the way. So if you're familiar with AWS, you'll get some context out of how to build on the AWS native services. If you're not familiar with AWS, you'll get a context of how to build an application because it's not easy. My clicker is playing. Okay, so the first thing that we need to do, we need to draw up a mock-up of what we're going to build. So if you think about the previous slide, we have the hideous whiteboards. This is Nirvana. So we sat down and went, okay, what does good look like? And so this is what we conceptualized as good. We had a nice dashboard at the back, which would cycle through all the question options and display the results in real time, so that as you put in an answer to a question like, what is my favorite development language, then you would see the answer pop up in the pie chart that's behind. you would put the answer into an app. So the app would typically, there'd be one or many of those sitting on a device that would be on the front of the booth. So for people who have been to developer conferences before, everybody is quite shy. Yeah, we're all quite shy. I'm quite shy. And so most people, when they engage at a booth, well, this is what I do, what I used to do. I used to put my head down and just walk over, pick up a sticker and leave. All right. So that's the engagement type of a developer. So that's why we built an app, the mobile app, because you can put your head down, you can walk over the booth, you can pick a sticker and you can answer a question. You're engaged. Brilliant. So this is what we conceptualized as our application. And this is a picture of it working. So this is at reInvent last year, the drawing reality. So we've got a screen behind us. We've got the pie chart on the right-hand side, and we've got our native applications, our mobile applications running to ask the questions. Talk over, thanks very much. There's more. So in a bit of detail, what the app actually did. So on the left-hand side, you would have a native app which would run on a Windows tablet. It would go through, cycle through a number of questions. The questions are configurable. So the favorite one is, what's your favorite programming language? The answers are configurable. So if you're running the application in Stockholm, might have a different scope of development languages you're interested in, as opposed to if you're running it in Sydney. So that's all configurable. As you answer a question, so if I answer Python, like a third of all developers that we ever talk to, then that will get sent and displayed in the dashboard, and the dashboard would cycle through all of the answers. The technology that we used was Blazor WebAssembly for the dashboard, and the new Xamarin, .NET MAUI. Has anybody used .NET MAUI yet? Yeah, we'll come on to that in a minute. On the client. So that's pretty simple in terms of pictures, but the architecture. So how we built this out. So we start with an architecture of our clients, which send MQTT messages to AWS IoT Core. So IoT Core is an IoT broker that lives in the AWS cloud. It grabs those messages that the client sent. So the client would send the question and the answer in a JSON payload. Very simple. But then you would have a Lambda rigged up to the IoT rule, because Lambda loves events. And this message coming through is an event. So we'd use AWS Lambda to listen to the IoT Core, and then it can spawn one or many functions. So if we have lots of messages, a Lambda will handle it, and we can parallelize the consumption of each message because they are unique. The messages themselves would then be persisted in Amazon DynamoDB, which is our NoSQL data store. And then we would run DynamoDB streams. So that is, if you think of it as a change data capture to the messages as they come in, we're actually going to enrich the message with a count. So for example, if I answer C# to my favorite language, it will be persisted in Amazon DynamoDB. That would kick off the stream to do the change data capture, which would then count how many C# messages were there, and then update that record with your count number, 10, 11, 12. So because streams is sequential, that works beautifully. So, and what we did as well is I was not going to build this myself, all of it. So what we did, we split up into geolocated teams. So we had a front end team situated in Australia and New Zealand. We had a back end team, which were in South America. And then we had the dashboard team, which were in Europe. And the dashboard team, they built the dashboard, as I said, in Blazor WebAssembly, listening for events of AWS AppSync. So AWS AppSync is AWS's managed GraphQL service, which spits out GraphQL messages. So it'll do subscriptions, It will do mutations, and the screens went off. Screens went off. Pick a few buttons. Didn't come back on. Oh. Don't touch the cable. Don't breathe on the cable. Yep. So AppSync. So queries, mutations, subscriptions. If you've used GraphQL before, has anybody used GraphQL before? A few people. So think of GraphQL as a different way of writing an API. You use REST as the way of writing your APIs. GraphQL is much more efficient. So AppSync then takes mutations. So a record has changed in DynamoDB, and that's how it notifies the dashboard that a result, so the new count for C#. So that way, from the client going, answer a question, this goes through the system, displayed on dashboard in real time. No polling happening here. It's all event-driven through the system. So what tech did we use? Well, we used .NET for the entire stack. There's a number of reasons why we use .NET for the entire stack. First of all the developers who were involved in this love building in .NET, C#. A lot of them may have had previous jobs in another cloud provider. A lot of them, like me, came from a .NET consultancy who just loved the language and the developer experience. And while we're working with AWS, we get a lot of questions about, oh, you can't build .NET on AWS. Oh, it's really hard. I have to use containers. Just a lot of repetitive questions. And so we thought, well, why don't we show everybody how to do it? Not using containers, using native services like Lambda, DynamoDB, AppSync to build this application out. So that's why we built it all in .NET. I need a new clicker. So the first stage we're going to talk about is the front end stage. So as I talked about it before, it's a .NET MAUI application running on a Windows tablet, sending MQTT messages to IoT Core. So some thoughts on .NET MAUI. So .NET MAUI is just over a year old. It is the natural progressor to Xamarin. So when I built my startup, I built two client apps, both in Xamarin Forms. And if you've built in Xamarin, you know that Xamarin Forms is not a real thing. You have to actually get into the native code to get it to work. So .NET MAUI was the evolution of that to try and make that Xamarin Forms easier and better and increase the developer experience, which was already pretty good in Xamarin, but .NET MAUI is bringing that to a new level. Now, .NET MAUI, because it's new, ran into a number of speed bumps along the way. So if you're considering .NET MAUI, I would probably run a proof of concept first and not commit to it. There's a lot of things that need to be ironed out first. So be aware of that. The developer experience is fantastic. It's really nice. It'll run on Windows. It'll run nicely on iOS. It'll run on Mac desktop, which is something that Xamarin didn't really do. And will also run on Android. So it's a nice cross-platform experience. I also build stuff in Flutter. I think Flutter's more evolved than .NET MAUI is at this particular time, but it's definitely a tool set and a framework that's worth investigating if you're looking at building a cross-platform client application. So luckily, as the project progressed, the client project progressed, we got a new member in the .NET Developer Advocate team, Brandon Minnick. So Brandon Minnick worked at Xamarin, got bought out by Microsoft and started on the MAUI port. He came up with this community toolkit, which is something you could get for Xamarin, and it makes life so much easier when you're building with Maui. So Brandon came onto the project and really helped by saying, Derek, what are you doing? You need to use the community toolkit for Maui. I know because I started it. It's my baby. So Brandon and I are very good friends now. I spoke with Brandon in Sydney. We talked at the Modern Applications group in Sydney, and he knows so much about Maui and Xamarin. It's not even funny. So if you're building .NET Maui, Community Toolkit, it's a absolutely no-brainer. Bring it in. By Nuget. The next question I get asked after I get asked about .NET Maui is why MQTT? So this comes down to the non-functional requirements of the application, which were basically, we don't want to lose an answer, right? So if I used a traditional API, like a RESTful API, and the network went down, I could potentially have lost that answer, that piece of data that the user was inputting. And considering the amount of effort that a developer goes through to answer this, i.e. sidles over and presses a button, I don't want to lose any answers. So MQTT enabled me to persist locally while it was reestablishing the connection, which meant I would never lose any answers. What also I used MQTT for was the facility built inside IoT Core to easily provision an MQTT broker that I could send the messages to. It's basically, I can do it. It's very simple. And so that was another reason why MQTT made sense. However, when you're dealing, has anybody used MQTT? Yeah, a few. So if a word of warning, MQTT and any security involved, there's a number of ways of securing an MQTT message. The mechanism that I use was certificates. So you can generate a certificate from IoT Core, which will trust the device it's installed on. That is painful because you have to install the certificate in all the devices that you're going to use. And anything that you want to install remotely that's not via an app store, good luck. Certs are a pain. There is a better way of doing this. You can actually do authentication and authorization where you can log into the device. It could connect to IoT Core and download a certificate. Do it that way. Luckily, somebody's already written an MQTT client. But not only that, they've written an extension method on this MQTT client that persists your messages locally, checks the connection state, and then sends and flushes the cache once it reconnects. I didn't write any of that code, which I like because I don't like writing code because developers are lazy. I'm lazy. Whoever wrote this is fantastic. So if you're writing MQTT on .NET, this library is a no-brainer, and the extension method for the managed client is genius. And it just worked. It worked first time. Okay, so that's enough theory. I'm going to take you through the code. So this is the way this talk's going to go. Slice of the architecture, why I made those decisions. Here's the code. Okay, let's see how the screen share works for this. So my development environment of choice is JetBrains Rider. Does anybody use Rider? Yes. Once you use Rider, you never go back. Never, ever. So I don't know. I've been a .NET developer for a very long time, and the first thing I did when I got a new version of Visual Studio, ReSharper. So Rider is the answer to all of that problem and pain. So I use Rider. Okay, so I'm going to take you through some of the classes that I use. I'll start with if you haven't used Maui before, the really nice bits of Maui. The first bit that's really nice is the dependency injection. So in Maui, there's a single entry point. And this, if you can see that, this is an excellent screen for this actually. This is how you add your services and your pages and your views as an injection. So use the default. This is default. This is not an extra NuGet package. This is Maui out of the box. Very cool, very nice. It all just works. Now, a couple of the pages in here, I've got a model. So the way Maui, well, the preferred way to structure a Maui project is MVVM. So this is structured in MVVM. And so the view model that I'm showing you now is the only view model we used, which was the question. So it had a question and an answer section. However, what I'm going to show you is this: observable property and notify property change. So this is all from the community toolkit. If I didn't bring those in and annotate the methods functions with them in the parameters and attributes, I would have to write a shed load of code to listen for events, to determine where they're from, and to work out what to do. This is all I need to do that, which is genius. So community toolkit. I talked about it earlier. This is why. Again, you don't have to write any code. Be a lazy developer. Don't write lots of code. Use somebody else's. All open source as well. So if it's wrong, you have the power to fix it. Genius. And then finally, the piece of the client that's really interesting is the MQTT service. So the MQTT service, it looks, this is it. So this is establishing the MQTT service, where you have to define where the properties are. So I've got broker properties here. So in broker properties, I've got the endpoint that I want to send the messages to, the port, and also the topic. So I need to send to the MQTT service. These are the messages going to this topic. So I set that all up, and I just do some null checks because I'm good like that. I then add specific keep alives. So this is telling the service that the client that retry this amount of times during this period, and use TLS as a security protocol, and that's it. Again, I didn't have to write any of this. I just called the library. Again, this also worked first time. Android, you'll get this in Maui a lot, and you got it in Xamarin as well. We have to do specific things for specific platforms. Unfortunately, there's no way around that because devices are different. And if you've been a mobile device developer for a while, like I have, then you know that this is painful. And if somebody ever works out how to do this, they are going to be rich. Next is the manage client. So this is the extension method. So this is where I set up the cache, pass in the options. If you see with client options, pass that in, and then define where my cache is going to be. And that is simply an implementation of the extension method, which is local client storage. The implementation is incredibly easy. I just go through. So you can also, these are just events that I can listen to. So for debugging and for logging and observability. But what I want to show you is the extension method implementation, which is here. So this is it. This one. So the extension, the interface is iManage Client, and the implementation is basically setting up a path to a local file. So this is where you store your messages, and that's it. It says check if it exists and then write it out. Save. That's it. There's nothing else you have to do. There's a save. There's a load. So CRUD CRUD updates. So these are the Mythic signatures in the interface. But this is basically, I think it's about 30 lines of code to handle retries, resyncing, all of that good stuff, which is, if you've ever had to write that logic, it's flipping painful. So this managed client does it nicely. So that is the Maui client. If you have any questions about any of the code that I'm going to go through today, come back. We'll have a chat, a cleansing beverage, and I'll go into a lot more detail. I just there's only so much you can get through in an hour. Happy to have that chat. Okay, so that is our friend, the client. Okay, so next we have our messages. They are being sent to IoT Core. We need to consume them and pass them into a persistence mechanism, which in this case is Amazon DynamoDB. We then, and this is the nice bit of Amazon DynamoDB, is Amazon DynamoDB Streams is out of the box. It's a tick box, enables streams, and it will capture as a stream all changes to that table in Dynamo. So that is a great little feature. So this slide has had many different words on it during its lifetime, because we sat down as a team and we all discussed what was our developer experience the first time we tried to write a Lambda function. And it was poor. It was really poor, because I've been at AWS 6 years. When I first moved over, I tried to write a .NET Lambda function. It wasn't straightforward. I was used to using a right-click publish scenario, which when I started AWS didn't exist. It does now, but back then it didn't. Luckily, as time has progressed, AWS has put a lot of time and effort into improving the developer experience for .NET devs on AWS. It's not terrible anymore, which is great. So what we came up with is, if I was starting again, what would I tell my past self? And so these are the things that I would tell my past self. If you're starting to build .NET apps on AWS, it doesn't matter if you're using the IDE or the CLI. The same commands are actually fed into what's happening. And once you understand that, everything becomes a lot easier. So the IDE, the commands all come from the AWS Toolkit, which you can get for Rider, you can get for Visual Studio Code, and its bigger cousin. You can get it for both, and that gives you that right-click publish functionality. But the CLI is where we like to live. And so here's an example of the right-click publish in the CLI. No IDE wizardry here. What we're doing is .NET new Lambda empty function. So Lambda empty function is actually a pre-published Lambda template. So there's a heap of these. I think I've got a slide showing you where to get them. So you choose your template that your Lambda function is going to be. This one is a simple empty function. You give it a name. You give it a profile. So that's what account you're going to connect and deploy it to. And then what region in that account. And that's it. I would recommend that when you're building and starting to build .NET on AWS, you get to know because the .NET CLI is everything. You know, as a .NET developer, it's something that you're comfortable with, something you should be using a lot. So creating a Lambda using it just makes sense. That's what we thought anyway. And so that's it. Lambda function created successfully. So a few words on Amazon DynamoDB. So we used it for a number of reasons. The primary reason was that inbuilt change data capture. So again, no code, it just works. Click button, we get a stream. That was a primary reason. But also there is the AWS SDK for .NET, and I'll show you that in the code. but that enables us to annotate fields that we want to persist in tables really, really simply. And also it allows us to call CRUD operations on DynamoDB really, really simply as well. There's a theme coming through this. Simple is good, lazy is better. When using Amazon DynamoDB, it also gives us, because when we first came up with the architecture, we didn't know how we were going to split. We knew that we wanted real-time notifications and real-time updates. So we wanted fast throughput. We wanted it to get to the end point as fast as it could. And so DynamoDB is custom built to do that, super fast to do that. And it's flat. So the data structure that we have is a message, question, and an answer. Very flat data structure, no relationships there. Makes sense to stick it in a NoSQL data store. So that's why we used Amazon DynamoDB. Okay, so that is the overview of the middle tier. And let's get into what it looks like. Okay, so here I've got, let me see if I can scroll in here. Yeah, works too. So here we've basically got a couple of different projects in here. We've got infrastructure, I'll talk about later. Ignore that, didn't happen when we first built it. It was 2 projects, aggregate vote and vote storage. Now we split it like this because when you're building Lambda, another question that I have a lot is Lambda bloat or Lambda for everything. And they go, Derek, well, how do I structure my code inside Lambdas so I don't have either of those? Because they don't make sense. And you're right, they don't make sense. What you need to think about when you're building your Lambdas is what events do you want that Lambda to consume? And what you want to do at the back of it. So you could have multiple Lambdas consuming one or many different events if they're all persisting in the same backend data store. That would make sense as a single project because it's basically a microservice. Although I don't like calling it that, but when you think about building Lambdas, don't build one for everything you can think of. You will get bloat. It will look horrible. Think about it more from a domain aspect. Think about where your domain is, what events exist within that domain, and what ultimately they're saving, persisting, CRUD operating on in the data store that they're acting with. So that's how you have to think about Lambdas, and that's how I think about Lambdas. So here we've got 2 events. We've got our initial vote. So our vote's coming through. It's persisting in Dynamo through our vote Lambda. And then we have our aggregate vote. So again, that's kicked off by the stream, does the count operation, and persists it back. They're the 2 events that this is for, and that's why it's structured like that. So the first thing I wanted to talk to you about is the vote class itself. So I talked about earlier, DynamoDB has a nice little AWS SDK for .NET. And this is why. So this is how I can map my objects to the attributes in a table. And that is the table defined programmatically. That's it. Very easy. Then we have a function hanging off. So the first one is the vote storage. So again, we've got a client. So we initialize init up the client and init up some context. And then in the handler itself, this is where we do our CRUD operations, which is usually just a save. So inside the handler, we, of course, if you're ever dealing with events, GUIDs are your friends. If you're not doing GUIDs, you're going to have a very bad day. That's all that I need to say there, please. Just do it. You new up the vote object, and then you persist it. And that's it. So that's all using the AWS .NET SDK for DynamoDB. That's it. And then the same for the aggregate vote. So I've got it open. So the aggregate aggregate vote. There we go. The aggregate vote itself is a little bit different because it has this property here called the count. And this is how we structure and the main purpose of the aggregate vote function is to update this count. And we'll see how that then gets relayed to the dashboard in the next section, but that count is very important. Another thing that you need to understand when you're building with DynamoDB is the hash key and the range key. So it's the ID, a unique field. And then for the aggregate vote itself, so again, this, even though this function is fired by a stream as opposed to IoT core. So if you go back to in your mind, go back to the architecture diagram, the vote function gets fired by IoT core. This aggregate vote function gets fired by stream. Even though the event sources are different, the way you initialize the client and the DB context is the same. So that's no extra thought has to actually come out of your brain when initializing the function. And then again, this is a process record. So every time you get an update in the stream, in the database, it goes into the stream, and then this is the process. And basically it's counting. So it's going, okay, give me the object, go through the object, and I'll update its count to a count +1. Very, very simple and very, very fast. And that's why we did the aggregate count like that. And that's it. So that now updates that count. So Lambda, I wanted to go into a bit more depth about Lambda. I talked about architectural thoughts and how many Lambdas make sense to implement or to create in your architecture. And you think about it in domain boundary land and not for every single event. But there's other thoughts that you need to really think about when you're building with Lambda. First of all is observability. So you want to make sure that you understand what's going on, because if you think about Lambda, it explodes the complexity of your application, because these are asynchronous tasks that can run one or many times, each doing a thing. So how do you make that observable? How do you work out when things go wrong? How do you backtrack and find the issue, and how do you fix it? So there's a number of things that I'll show you that will, in fact, one thing that I'll show you that will make that really, really simple. The other thing about Lambda that you need to think about is how to easily write less code. So a lot of people and a lot of Lambdas that I see are very, very complex. And once you're writing, and this goes to the argument for the mono function, where people write all of their code in one function, which makes that function so complex that you reduce you add an overhead that negates the fact that you had to write it in the first place, because you got a unit test look ridiculously long. To run it is ridiculously complex. So try to reduce the scope and size of your Lambda functions, which means write less code. There's two open source projects I'm going to highlight now that you should be using if you're writing Lambda functions. And these are them. First one is Lambda Power Tools. So Lambda Power Tools allows you to annotate a function with a log or a metric. And what Lambda Power Tools does, it actually contains all the code that writes the log in the right format. It applies the right metric, and also you can annotate it with traces as well. So you can use Lambda Power Tools to do all of that heavy lifting and all of that evil code. I call it evil code because it's really painful to write. that spits out all of your metrics, spits out of your logs, and makes sure that they are correctly formatted. So it makes the task of finding the issues in your Lambda functions a lot easier. So if you are writing Lambdas, or if you're starting to write Lambdas, Lambda Power Tools. Lambda Power Tools also, as well as .NET, comes in a lot of other flavors as well. And I did have the documentation. I'm not sure if I've still got it. Wanted to share it with you. Just testing my. Yes, so this is the documentation for Power Tools. So the Lambda one the .NET one comes with tracing, a logger, and metrics. And so, for example, the logger one, which is the one that we use the most, we show you what sort of logging levels you can add to your environment and what information you need in your logs, and it will do that for you just by annotating one line on top of the function signature. Very cool. The next one, and one that I was surprised didn't exist, was Amazon. So Lambda annotations. So annotations, and this has just come out. So annotations, you can now use annotations in Lambda functions that are written in C#. So again, if you're writing C# code and you're not using annotations, you should. And now you can also use the same annotations inside the Lambda functions. Again, the theme with annotations are you don't have to write the code. Somebody else has written it for you, and you simply inject the annotation above the method signature. So check out annotations as well. They'll help you. So the reason I'm mentioning both of these projects is because that we got through the development churn, and we started to find bugs in what we were writing. And so what helped us and saved a heap of time, because we had a hard deadline of reInvent, was these two tools. So we initially, Power Tools was a biggie. We put Power Tools in, and it made fault finding so easy, and tracing. And then with annotations, it just put the icing on the cake. So please look at those when you're building Lambdas in .NET. Okay, so that's the easy part over. So the next part is the real-time updates into a Blazor WebAssembly dashboard, all using AWS AppSync. So this turned out to be the hardest part. It's complex in a number of reasons. I'll get into it. First of all, Blazor WebAssembly. Has anybody used Blazor WebAssembly or Blazor? Yes, you used everything. Nice. So Blazor and WebAssembly. So WebAssembly is cool, fast, super fast web pages natively rendered in your browser. Excellent. Blazor, you don't have to be an expert in JavaScript to write web pages. Super excellent. So it's like a double positive, Blazor WebAssembly. So we decided to build our dashboard in that, even though we were not front-end developers, right? And you've seen the screenshots. Obviously not a front-end developer. Boxes, circles, that's as fancy as it gets, really. So we decided to stay away from JavaScript, and Blazor WebAssembly was the right choice for that. So that was one side of the complexity. We'd never used it before. The second side of the complexity was AWS AppSync. So GraphQL, again, GraphQL adoption. I do some talks on GraphQL, but what we're seeing is the adoption of GraphQL is growing 50% year on year. So what used to be, when I first started talking about it 4 or 5 years ago, nobody was using. It's really gaining adoption for client APIs, and also for data mutations in the ETL. So we're using this for basically an ETL to a dashboard. So AppSync and GraphQL have those two main use cases. And so what we're going to do is get into that. So as I said before, Blazor WebAssembly. So we weren't front-end developers, so we needed a library that would give us, well, sort of convince people that maybe this had some designer thing going on. So we chose MudBlazor, which is actually material design out of the box, which you can plug in. So we use MudBlazor because material design, everybody's familiar with it, everybody uses it. So that was a no-brainer. And we also completely killed JavaScript, which was excellent, and it was open sourced under MIT. Again, for the UI, Plotly. So plotly.blazor, if you used any of these libraries. So Plotly is if you want to draw graphs. Drawing graphs is hard. If anybody's ever drawn a graph on a website, on a web page, it's hard. That's why there's dashboarding applications out there to do that for you. So plotly.blazor is one that will do that for you very nicely. And it wraps the plotly.js library. So if you not even use Blazor, plotly.js should be something you look at because it's a nice little graph rendering framework. Again, licensed under MIT. So I've touched on AppSync a few times. So it is fully managed. So when we talk about fully managed services on AWS, it's something that you can create a GraphQL server, and we will manage the infrastructure and all of that good stuff underneath. And you just have to think about writing a GraphQL schema and how to interact with your data sources. And then the absolute star of the show in this stage of the architecture is Strawberry Shake. Yes, nod, nod, nod. Yes, Strawberry Shake is gold. So Strawberry Shake is an open source GraphQL client. So to connect to AWS AppSync, obviously you need a client library to do that. So Strawberry Shake is one written in .NET. It is compliant with all GraphQL servers, but also, and I don't even know if I've written it there, once it connects, it will auto-generate the GraphQL schema, which is fantastic. So removing not only the complexity, I say there, of state management, but also the complexity of trying to keep your client and server GraphQL schema in sync. So if you haven't used GraphQL before, the schema defines the endpoint, defines what objects you can send to it. It defines how you can change, mutate things among other things. And again, Strawberry Shake is open source. So I'm going to spend a little bit of time on Strawberry Shake and talking about how excellent it was. Because when I say there that Strawberry Shake is compatible with all GraphQL compliant servers, correct. There's three operations in a GraphQL server. There's query to query the data. There's mutation to mutate the data. And then there's subscriptions. Query and mutation work over HTTP. They're an HTTP post. Very easy to do. Subscriptions are a bit more complex. They work over WebSockets. WebSocket implementations are not fundamentally, there's no defined, or there is a defined way of implementing one, but you don't have to do it. It's not like an HTTP post where it's clearly defined and you have to implement it this way. WebSockets, you don't. And so what we found is when we plugged in Strawberry Shake to AppSync, the queries and the mutations worked lovely. The subscriptions did not, because AppSync did not implement WebSockets the way that Strawberry Shake thought that we should have. But Strawberry Shake comes with an extension method that you can implement your implementation of WebSockets. And so what we ended up doing is writing that WebSocket implementation inside the extension method for Strawberry Shake, and it works like a charm. because at one stage we were like, I have no idea how we're going to get this to work. So thank you, Strawberry Shake. Thank you very much.
So a comment from Paul in the chat saying he's currently using a web ASCII server to do a remote telemetry dashboard, and the Signal are updating UI. The DOM that's bound to data model is fabulous.
Yep.
Just sends what changed, quite responsive.
Yep. It's very, very fast. So AWS AppSync, I was just going to go through exactly what I've just explained when I was explaining Strawberry Shake. For the managed service that it is, you will get GraphQL mutations and subscriptions. Mutations and queries. There are existing clients for JavaScript, and I think that's it. We have written a .NET 1. Because we have written a .NET 1, that's opened up other teams that I know of who are writing other clients for AWS AppSync to implement the WebSocket subscriptions. Now, the reason, because when this happened, we have the advantage of going to the service teams, and I know the product manager for AppSync. He's left now. And we asked him why did you implement WebSockets differently? And the simple answer was, Derek, scale. And I went, oh, okay. And then he explained to me the scale of the AppSync WebSocket implementation. And it all made sense. Unfortunately, I can't share, but there's always a good reason that things are the way they are. The good news is you can use AppSync. You just have to write the WebSocket implementation. Unless you're using JavaScript. Okay, so this is, if you haven't come across, this is your chance to use Strawberry Shake. You will not be disappointed. It's excellent. Again, every project that I show today is all open source. I am a bit biased towards open source. I run a bi-weekly open source show on Twitch. So this is open source as well. Okay, let's get into that code. Dashboard. Okay, so there's one thing I just wanted to start with was the schema. So this was actually the schema that was automatically generated by Strawberry Shake, which is identical to this schema that is deployed on AppSync. So what you'll see is query, mutation, and subscription. You'll have the query. So in this case, and I'll get into the code in a minute, our query is really badly named, right? Poll result. We're not polling. This is not a poll. This is a poll. No, it's really badly named. So there's no polling at all happening. It's named after, because we're answering questions on a poll, right? Oh. So please, I apologize. I only realized when I was going through this code today, I was like, that's a terrible name for an object. So there's the poll result that it wants to retrieve, and then the mutation, which is updating it. It should have been question, update question. You know, that would make more sense, but poll. And the mutation's there, and the subscription is there, and there's the auto-generated code, so you know that it was created by Strawberry Shake. The next bit I wanted to show you was the implementation. So there's a lot of stuff here. I just wanted to show you what I did. So here you'll see that in services, I'm adding a scope service, which is an HTTP client. All right. So if you know, earlier I was talking about HTTP posts. This is to handle the queries and mutations that you want to send from the client to AppSync. Then I've got this terrible if debug statement, if not debug. So this is so we can test this really. So you will inject the endpoint if you're in production, and so that is the injection code, so that the endpoint and the parameters for the endpoint are not exposed. But if it's not, we can simply API key and URL. So this is all dead. So this is this is a dev API and URL key that we've killed subsequently. So that is the URL of the AppSync service. Then I'll get back to this in a second. This is the lovely extension method for Strawberry Shake. So this is where we're implementing our WebSockets. And then this is the GraphQL client. So I've configured the GraphQL client this time because I had to configure it with two different things. I had to configure it with HTTP for queries and mutations, and then again for WebSockets. And then once that's configured, it will jump into when it runs the WebSocket code. So the subscriptions, it will jump into WebSocket Protocol Factory, which is where it will initialize the WebSocket and then get updates from it. Finally, I wanted to just, this is the Blazor WebAssembly carousel. We'll see there we're using MUD. And I wanted to show simply what happens. So this is the uninitialized async. So as the app loads for the first time, so the app being the dashboard, so it's a single page app. It's the pie chart or multiple pie charts. The first thing it needs to do is load what's there. So it calls that load data function, which is basically sits and gives me all of the aggregate votes that currently exist. I'll jump into it in a second. Then once we've done that, we then want to initialize our WebSocket to listen for all further updates. So that is subscribe to update and what that does. And then the last part is start transition timer, because what we find is you want the dashboards, because there's one or many dashboards depending on one or many questions. So what's your favorite programming language? What's your favorite service? You know, that sort of thing. So we wanted that to scroll. So that's the transition timer. Again, there's no JavaScript here, just C# code. And let me just get rid of these. I'm going to get rid of this because. Okay, so now we've got our load. I've got it down here. Yeah, load first. So basically what I do is I get the response from the load data, check it for any errors, and then iterate through it and add it to the poll data, which is a really badly named object. And then once that's finished, you get subscribe to update, which is an async, invoke async, because obviously this is happening in the background off the UI thread. You don't want this to be happening in the UI thread. That would be very unresponsive. So it's an invoke async. It checks all the errors, checks the data is good, and then updates it. And it's super, super fast. So when we were running this, we would get a second and sub-second updates from the client to the dashboard. It was super fast. So that's the synchronization code there. Again, I'm happy to. I could go into depth. I could go into so much depth on any of these things, but yeah, that's might take questions. Actually, would be the way to do it at the end. So that, in a nutshell, is how we wrote the dashboard. So next, we were like, yes, we've written everything. It's all done, and happy days. We went to reInvent, which was our first ever conference, and it worked like a charm. We got, I think, 1,000 questions answered over the 2 days or 2 or 3 days it was at reInvent, and a lot of great feedback from developers about the application. But then we got beyond reInvent, and because of its popularity, we got other conferences asking about, well, when can we get DevPulse at our conference? And we went, oh bugger, we haven't automated everything. We are in trouble. So if you haven't written a pipeline or written automation, you will know that things can go pretty badly pretty quickly unless you can deploy a change pretty quickly. So we were a victim of our own success. So this is the top one is Singapore. I think we had about 700 or 800 questions there. That's Sydney. We had a queue. The queue stretches all the way around, answering DevPulse. And all we were giving people was socks. So we became a victim of our own success because this grew beyond what we had thought it was. It was supposed to be a demo. And so we went, oh, bugger. We're going to have to write, we're going to have to automate this entire thing so we can support Sydney, Singapore, Paris, Stockholm, and many more. And there have been many more. And so far, and that was a figure I got this evening, 20,000 questions answered to date. So we had a problem. We had an application that was out there. We had written it, but we hadn't automated it. If I was talking to myself about this, I would call Derek a very bad boy, because writing something and not building infrastructure as code and automation is a no-no. Never ever do it. Write your infrastructure as code with your application. Otherwise, you'll find yourself in this problem where you have an application in production and the length between changes in features is weeks, not hours and days. You need to automate. And so when we thought about automating it, we had a number of different technologies we could have chosen. We could have chosen Pulumi. We could have chosen straight CloudFormation. Why? I don't know. Anything written in JSON and YAML is well to be avoided. So we wanted to write our infrastructure as code in C# because that's the app. The whole app is written in C#. So we decided let's write our infrastructure as code in C#. So we use the AWS Cloud Development Kit. So this is a slide about the AWS Development Kit. What it does is it builds your infrastructure as code. So it supports all of those languages, C#, bottom right. So we could take our C# code and provision the infrastructure that we needed to run our application on. So if we needed a backend for Sydney, we could provision that right away. If we had a bug found in Sydney, we could fix it in our code and provision it in Stockholm. And we could do that in a few minutes. So the Cloud Development Kit is what we chose. It comes, if you've used it before, it's like, it's all the advantages of using code. So you can unit test it. It will get you IntelliSense. You can love it like I do. So that is what we used for infrastructure as code. So I'll take you through what that looks like. Again, the structure of these projects is something to be aware of and how we did that. Okay, so here is the CDK program. Let me show you this structure. So what we provisioned there, you can sort of see it. There are 3 projects there. We have our backend processing, so that's our ingestion of our messages. We have our CDK app, which is like almost an entry point to the CDK app. And then we have our dashboard code, so the app sync stuff and the website and all of that. Now, we structured it like this because if you remember at the start, we were diverse teams: Australia, Europe, South America. Everybody had a responsibility. So we were able to share that responsibility by structuring our application like this. So the CDK app is the entry point. And so you run, let me show you actually. You run a CDK app by just calling program. So that then opens this up to be run on any orchestration engine that you want, because You can run it on Code Pipeline. You can run it on Azure DevOps to orchestrate it. You can run it on any orchestration engine that you choose to use to orchestrate your build pipelines, because it's a program. And so you start off the CDK app, you inject your parameters. So what environment you want to go to, what account you want to go to, what region you want to go to is injected in here. And so the outcome is the bundling of the infrastructure as code for that particular endpoint. And so that enables you to have not only the dev integration and production environment that most people have, but you can also be regional, which is a nice little feature that we can do. And it suits our purpose perfectly. So again, you just new up the app, you pull in the different parts of the app. So I'm reaching into the other projects and pulling them out, provisioning the initial DynamoDB table, and that's it. Then I go into the various stacks. So here, again, let's show you some code. So this is how you provision a DynamoDB table in CDK. So you give it a name. You give it a billing mode. There are a number of different billing modes for DynamoDB. There's a lot of debate on the best one. Grab me for a beer, and I'll take you through what's best for each. You set your partition key. So if you remember, we had that already in the structure, in the vote structure. So our partition key is question, and our name is sort. And then you add your index. So in this case, it's the answer count. Again, you provision your lambdas. So what's interesting about that, and ties back really nicely into the slide that I showed you, is using the CLI. So if you use a CLI to create your Lambda functions, then automating the provisioning of them is easy, because you're not relying on an IDE and the magic that it does underneath. You know exactly the CLI command that you want to run to provision. And so that really helps. And then you set up your vote function and your aggregate vote function as well. So this is a Lambda function. And you can set memory size and maximum timeout and stuff like that. And then finally, for the dashboard is a little bit more complex. I think because it lives as a single page app, you have to provision an Amazon S3 bucket. So applications and web applications run on S3. So you provision S3, and then in front of that, you need a CDN. So CloudFront is a CDN. So we provision both of those in that piece of code. And then once we've got that, we then run the code that actually publishes it to that S3 bucket that we're provisioned. So using simple .NET Publish to do that. We then open it up to the world, and that is it. And we also so the output command is interesting because it gives us all the output that we need. So if you need to know where the URL is that we've published to, it can output that in the build output, which is very handy. So that's all CDK'd. And then AppSync is a bit more. And again, I can go through that in detail, but really these are published APIs as part of the AWS .NET CDK. Okay. CDK. So during that experience, we learned a lot, and I'm sharing it all with you today, and hopefully you can take some takeaways from it as well. IoT Core for .NET app communicating with AWS IoT Core over MQTT was super simple because of the MQTT net library and its extension method. It literally worked first time. The complexity was around the certificates, but you can get around the certificates by thinking about how you're going to authorize the app, and that would be a nice way to go. You .NET 6 functions, you can run them on Lambda. It was really, again, easier to do than it had been in the past. So that developer experience has really changed, and it's really starting to come together. We also realized that there's lovely annotations for the DynamoDB for provisioning and interacting with DynamoDB. It's super easy. We were under, and a lot of times when I talk to developers, they're like, oh, I can only use JavaScript, or I can only use Python when I'm communicating with Dynamo. Well, that's not true. There are other great APIs, and the .NET one is one of those. AppSync you can use. It is possible, and we have done it. You just have to be aware that when you see your subscriptions not working, you go to Strawberry Shake and you implement that extension method, and they will start working. And then CDK, stay away. Tell anybody that Derek told you to stay away from JSON and YAML. Write your infrastructure as code as code. You will have a much better time at it than trying to fix where a bracket's not closing or where a tab is in the wrong spot. Kill me now. There are all the links. So a lot of stuff and a lot of resources are there on getting started with .NET on AWS. These are the ones that I would use. We have a whole developer center that will get you started and help you get started, help you with the terminology and all of that good stuff. There is a .NET workshop for building CDK apps. There are also the AWS toolkit. So I mentioned that at the start, which is what you have to plug into the IDE to get all of the great stuff. So actually, I have that plugged into my IDE. So if I show you, so this is the toolkit here. So it gives me all different what I'm currently running on AWS. And also it gives you how to set up your developer tools, like Code Whisperer and Code Catalyst. So Code Whisperer, if you haven't come across it before, is our AI plugin to help you write code faster in IDEs. And Code Catalyst is how you can automate an orchestration mechanism for builds. Okay. Coming to the end now. So I am in Adelaide. I just make a shout out to the AWS user group, which is also in Adelaide. And we have one of the organizers of the AWS user group here today. Hi, Andy. See you at the back there. So the next one is next week. So if you're interested in Cloud Native Earth Observation and Open Data Cube, you're more than welcome. Very friendly bunch. And there's always beers and pizza. So thanks very much for listening. If feedback is a gift, if you give me feedback, you also get a $50 US AWS credit. That'd be much appreciated. Even if you don't care about the credit, it'd be really good to get your feedback on how I can improve this talk, how I can give more with less, how I can be a lazy developer and give you more information with less talking. That would be great. Just please give me some feedback. And thank you very much.